So what I do here, we are going to create a neural network now. So first I import this NumPy library. It is for creating array. Then we create one function. This function name is neural net. Whatever you can use it. Say for example, you can use color or whatever. It doesn't matter. Okay. And then there's a two output. One is length and width. Sorry, two input parameters, length and width. Another two input parameters, say random two weights, weight 1 and weight 2, and one bias. So our formula looks like L into L1, L into W1, that is length into weight 1 plus weight into width into weight 2 and bias. We add this, we calculate this and store inside a variable name Z, and then we return this sigmoid value of Z. Okay, and how you call this sigmoid value? So sigmoid is nothing but 1 by 1 plus e to the power minus x. So this is how you can formulate it: 1 by 1 plus e to the power minus x. So here NP means NP is the NumPy array through which we can create this exponential. Okay. Now this is the this neural network function has been designed. Now we calculate some random weights. Say W1 is equal to np dot random dot rand n. So through which you can get some random value. Okay, because I have not executed this one, that is why it gives the error. So if you print W1, you can get some random value every time. So -1, sometimes you get minus 0.42, sometimes it's 0.09, and so on. Okay, so these are the random values going to be generated. Similarly, we are going to generate the random value for W2 and random value for B. So the value of W1, W2, and B, we don't have any intervention. We don't have any choice that what is the value of W1, W2, and B. So this is the now our aim is to we are predicting 3 and 1.5. 3 and 1.5 means, say for example here 3 and 1.5, it is red. So let's see whether it is so it's red or not. So see, 0.2 means it is very closer to 0. So 0 means blue. We set 1. We set 1 for red and 2 for 0 for blue. So here it is 3 and 1.5. It is showing the red. Actually, it is red, but we got the blue. Now, example 2 and 1. So let's see 2 and 1. So I put 2 and 1. Let's see. Okay, 2 and 1. It is blue. Actually, it is blue, and we got also blue. Okay, so that means our model is working, but it is not working perfectly. And there's nothing wrong with this model. Why? We define some functions. We ask that design these parameters. We give some input variables like weight 1, weight 2, and bias. And based on this, we get this. We try to achieve some prediction. Now, this prediction is not correct every time. Sometimes it is correct, sometimes it is not. Why it is? The reason behind here, our model is not get trained properly. There is some error is error occur. Say in this case there is a no error occur. 0.24 model is not understand that whether two length and one width means the petal color is blue. We nowhere we mention this. So that means we are sending some random values, and based on the random values it generates the random points. If this generated random points or generated result similar to my prediction, then we can say okay, this is correct. If it is not actual value, then not related to the actual value, then okay, we can say our prediction is wrong. So what does it mean? We have to mitigate this error. So how we mitigate this error? Now this concept of back propagation come into the picture. So this is how you can implement a neural network, but there is no training done as of now. So we have to train our model based on the error. So let now again come into the slide. Say as of now we are talking about there's a two input 1 and 2, and we are creating the activation functions through which we can get the type of variables here, the mechanism of evaluation. Simply we calculate the summation of wi xi plus b, then we calculate the output. Now here instead of calculating the output, we are calculating the y hat. What is y hat here? Y hat is the prediction result which may be different from the actual output y. So y hat, suppose 0.24 earlier in case of our explanation, 0.24 is the y hat value, whereas y value is say for example 1. So the difference from y to y hat, that is using some, we have to calculate some cost function. Based on the cost function, we can reduce the error. Okay, so our aim is to reduce the error using some cost function. So this is the cost function through which we can use it. So y minus y hat square. And then once we calculate this cost function, we again feed this information to my y hat. Okay, this is the error. Now once y hat understand the error, it's going to and send the feedback to this neuron. Okay, set the error where you change your W1 and W2. So here, suppose you are going to update the W1 and W2 value. So earlier W1 and W2 value, suppose something else, it is going to be change the W. So this concept is known as the back propagation. Okay, so back propagate. Earlier we are doing some only the feed forward. Okay, we are going only the this direction. Now we are first go to the feed forward, again come to the backward. So that is why back propagation technique it is known as. And when you're talking about the cost function, so our aim is to minimize this cost. So the lower I minimize this cost, we can get the best result. Okay. So how we minimize this cost is one of the technique is known as gradient descent. There is a stochastic gradient descent is also there. So with the help of these, we can usually reduce the cost. Okay. I'm skipping this slide that how we calculate the gradient descent because I have to show some implementation also. So this is the back propagation technique that I have already discussed. So just summarize this deep learning techniques. So first we have to randomly initialize weights to very small number close to 0, but obviously not 0. Then second step is to input the first observation from the data set, and calculate the features and feed forward to the our neuron. Okay, and neuron get some results, and once the neuron gets some result, it's going to predict the y hat. We are calculate the difference from actual minus y hat, that means y minus y hat, and then we are try to minimize the error, and then we repeat the same thing until unless we get a correct result. Okay, so this is how our model is going to be trained. So with this, I will start the coding section. As of now, if you have any queries, please we can discuss if you have any. Okay. So let's start the coding section. Here I going to explain two things. One is data pre-processing, and second one is ANN implementation. These two things I'm going to. And these two are very much important. This data pre-processing is really very much important. If your data is not pre-processed properly, then whether you are using ANN or CNN or any other machine learning algorithm, you never get accurate output. Never. Okay. So data pre-processing is one of the major area. Say okay. Okay, so I have two files here. One is ce.csv and dataset 114.csv. So first I am using this dataset 114.csv. Okay, so this is the data here. From here, suppose we can predict the UTS value, tensile strength, elongation, yield strength based on this 4 input parameter. Okay, say hardness is one of the parameter, shear strength is another parameter, fatigue, elasticity, these are the parameter. Based on the input parameter, we can predict this or this. So now for training purpose, we have this all the information. From this we can, if this is predicted properly, then we can obviously we can do the same thing for other materials also, if these 4 parameters are available. Okay, but before that, try to understand that this column, this row do not have any value. It's do not contain any value. So like this columns, other properties. Okay, having no properties. Now here somewhere it is written as NA. Okay, this elongation is NA. Okay, so maybe some other value is NA. So it is very small amount of data. We have 113 sample. Okay, so in 113 sample we can generally for this obviously to overcome data processing, for 113 sample we need not to use the data processing, because manually we can do that. The time required to omit these data, these missing values, to fill some values using the Python code, it is obviously very much more than the manual intervention, is not it? So in that case, Python code or coding concept is not good. But generally what happened, this data are not only this much, it is huge amount of data. Suppose instead of 113, if it is 1013, then it is somehow difficult to us that whether we can easily identify each and every null object or any values or empty fields. Okay, so with this I am pre-process the data. So for data pre-processing, we are using this value, this library, which is known as pandas. So we import pandas as PD. We also use some essential libraries like NumPy, matplotlib to if we need to plot something, and then C1. So matplotlib and C1, these are the for visualization purpose. Okay, and then we using sklearn model, we are going to split train and test. So this thing I'm going to discuss later, that how you split it. As of now, I'm using pandas only. Okay, but I all together run in very one shot. Okay, so first we have to take the input from the our location. So we can write, say for example, metal is equal to pd dot read csv. Okay, I'm writing here so it so that you can it is easy to understand for all of us. Uh, though I have the pre-written code for this, but not all the codes I'm going to copy it, because then it is not those who are really work for the very first time nowadays. So for them it is maybe helpful. Okay. So the file name is dataset11.4.csv. So I'm just execute it. Execute. Now, if you want to print the first 5 values, so simply write metal dot head. The head gives you the first 5 values. Similarly, if you want to print the first 10 values, so you can write inside the 10. So you get the first 10 values. So for last 10 values, you can get the tail, and so on. Okay. So this is how you can input the data. That is suppose not this color. It also describe the, if you want to describe this statistical information, you can get the mean value, standard deviation value from this. Now from here you can find that okay, there are some NaN value. NaN value means the empty values. So these are the empty values. No? So these are the empty values. So null values we can say, not a numeric. So NaN means not a numeric. Okay, here not a numeric. Here you can find not a numeric. Okay. And there are so many. I am just showing here only 1022 to 1111. Maybe there are other NaN values also there. Okay. So our aim is to pre-process the data. So now this data pre-processing is coming to the picture. First is we have to identify the missing values. Then we standardize in the data, normalize in the data, and we can binding the data. Okay. So what is the difference between standardization and normalization, that we will discuss later. So what I do, I just take this DEF is equal to metal. So I'm taking this metal inside a DEF so that my metal, which is the actual input, would remain same. So it is just like a temporary data frame. Okay. Uh, so now our aim is to understand that whether any null value is there or not. Here we can see the null values. So still we are we are not able to identify how many null values are there. So how to do that? So df dot is na is a function. You can get either true or a false result. Okay. So see, true means there is a null value. Okay, not a numeric value. So see here, the, in first row there's a no value, so that is why it is true. And here also no values. So first values are there, rest all are the null. That is why you can see at the 8th, you can see that first value is there, false, and rest all are true. Similarly, there are certain true and false values. Now again, the problem is same. So we are going to scroll these and count how many null values are there. So our answer is obviously not. Okay. So what do? We just calculate the sum. How many uh, null values are there? So for UTS there is one null value. For elongations, sorry, Yellowstone there is one null value. For elongation there is 5 null value, and so on. Okay. So each and every element having one null value, whereas elongation having 5 null value. So we can do the from here. It is clear that this row, this column, say other property column having continuous null value. So this column is not useful to us. Okay. Uh, because when all those parameter, how you understand that all these that other properties are having one having null values. See here you can see 1 on 12. So total sample is 1112. Total sample is 1112. It is 1112. So out of 1112, all these cell having null, so empty. So that means one this other property is not going to required uh, in our case. Okay. So what to do? We can directly remove this. So how do we remove? So we can remove df dot in. Okay. We are going to remove df dot. So now if you remove this df dot drop in it, so it is remove all the null parameter. Okay. So total number of sample is 1112 now. So if you drop in it, if you find this, so it's remove all the null. So it's row wise you get all the null value, because here in each and every row there is a null value. See, all value, all the row containing this other property. So that means each row containing a null value. So that is why it's deleted all the null value. So which is not desirable. Our aim is to, okay, one more thing. So this is delete this drop in a delete row wise. Okay, it is delete row wise. If you want to delete column wise, that we can do, but here it is row wise only. So for column wise, if you want to do column wise, you can write axis is equal to 1. Okay. So here see you can find, and each every column there is a null value. So apart from this alloy and temper, all these values are all these columns are having a null value. So that means this is not the good function to use. So how to do it? So first we are going to drop our property, that is the other properties. So first I drop other properties. Okay. Let's see. Okay. So other properties not found in axis. So as I told you that by default it is performed from row. So that is why we have to move to the column, axis is equal to 1. So column means 1, and by default is 0. Axis is 0 means row. Okay. So see here you cannot find the other property column. Okay. So these 4 columns are there. And also say for example this alloy and temper is not required for us as of now. So we can remove this alloy and temper also. So we can remove this alloy and temper also because it is not going to useful. Okay, so I'm just a bit, do this. When we delete 2 or more, then you have to write this alloy and temper is also removed. Okay. So now we have UTS, US elongation, this, hardness, USS, fatigue and elasticity. Now from here you can remove this NaN. So now if you write simply, say for example, df dot prop, again it is remove all this because okay obviously, but because we are not save this to somewhere. So I am saving it, say for example df1, I am saving it inside the df1. Okay. So now df1 dot drop NA. So you can find total number of rows. Earlier it is 1112, now it is 107. Why it is? It's remove all the NA. All the NA. So drop NA means wherever NA are there, all NA are there. For example, it remove this, it also remove this one. Okay, so this entire row is going to be deleted. So for example, if you do not want to delete all the NA, so you can write how equal to all. So that means if all row are having the NA values, then only it will be deleted, otherwise it is not. So see, you can find 1112. Total number of file is total number of rows are 1112. Now it is only 1111, and you can find that NaN value is there. Okay. So what to do with this NaN values? Okay, what to do with these NaN values? So whether we remain it as it is, if it is, then obviously your program is not going to work. So now it is our call. We can delete all the NaNs, so it obviously reduce our data set. And if somehow it is so I write df1 is equal to this, so that score is. So if somehow we can manage that whatever the previous value, we can store it here to that. So if it is work, then we can do it. If we can use 0 value instead of NA, we can use it. So suppose I want to fill df1 dot fill NA with 0. So I want to fill all the NA value to 0. So I fill all the NA value to 0. See here, earlier NaN is there, so I fill it with 0. Okay. It might possible, so you may say that, okay, if we put 0, that means it may be not work properly. So in that case, we can just copy and paste the previous value. So 13 here it is. So okay, we put this instead of NA, we can put the 13 value. So in that case, we can write as a method is equal to ffill, forward fill. So now you can see instead of 0, you can find 12, 2 times 12. Okay, if there is last values are there, see here 12 values are there. So this one. So row number 107, you can find instead of NA it is now 12. So instead of NA in 106, sorry, you can find 12 instead of NA. Okay, so this is how we can use different data cleaning process. So this is how you can fill your data. Okay, so this is one of the example. Now I move to the another section that I want to divide this data into two parts. One is for training, another is for testing. Okay. And then we move towards the features scaling. So divided into training and testing. For that, we have this one, train test split. So why do we use this? We can by our own we can do the same thing, but here the splitting is random. So for example, we can split our data from here to here as our training data and rest are our testing data. But using this, we can randomly split. We don't know which row are in training under training section and which row is under testing section. Okay, so that is the one of the most advantages, and obviously it takes less time. That is one of the main reason. Okay, now so to divide it, what I do, I just write, say for example, just a minute. Again, write df1 is equal to this so that you can save it. Now I stored, say we split it into two parts. One is x. So x contains the df1 of all these parameters, say UTS, elongation and hardness. Okay. Say hardness, it takes hardness. I have this so that I need not to copy this thing again and again. So paste it here. Hardness, USS, fatigue, and elasticity are inside this X. So these are the input features, and UTS is going to be my output features. Okay. So from here you can see that how your X looks like. So it looks like X only have your these four values, and Y is having these four values. Okay. Now our aim is to split this result. So when we split it, we split into four parts. Two parts for training and two parts for testing. So X train, X test, Y train, and Y test. This is up to you. Whatever you can, whatever name you wish, you can give. This is the general name. And then there is a function name, train test split. Train test split. This is the function. This function going to split your data, and it's split parts: training, testing, X train, X test, Y train, and Y test. Okay. So what to split? X. Okay, and what another is Y. So X and Y going to split. X and Y means this X and Y. So these two argument is going to be passed. Another, what is the test size? Say you are using 80-40 ratio, sorry, 80-20 ratio or 60-40 ratio, something like that. So we have to write test underscore size. So this is 0.02. Okay. And you can say the random state. So how many states is going to be designed? So you can put the random state, you cannot, it's up to you. So these three are the essential parameters. Okay. So X, Y, so that is the these input values, and the test size. Okay. So if you execute it, so it's invalid parameter passed. Invalid parameter test. Okay, sorry, it is text, not text. Now you can see if you print it, extend so you get the training values and 88. So out of 111, 88 is used for extend, and these values are used for X test. Similarly, Y test, for Y test, there are near about 20 values are used in case of Y test, and Y train there are 80 something, 86 or 88 values are going to use. Okay, so this is all about the test. Now, second important term is feature scaling. So this is how you can split features. And here these are the index, row index. No? So first it's Y10 is 60, then then 106, then 4, then 5, 54, 94. So these are random numbers. This is not sequential. It is random rows. It is okay. One of the more important feature is feature scaling. So in feature scaling, we use generally the concept of data standardization or data normalization. So the difference between normalization and standardization are only that in both the cases, in standardization and normalization, in both the cases, we generally use we scale the input data. But in case of normalization, we choose a value, mean and variance from 0 to 1. In case of standardization, we use mean value to 0 and standard deviation to 1. Simply. The rest all are more or less same. Okay. So here I have one feature scaling parameter that I have already used. Say sklan dot preprocessing is the package. From here we standard scale, and so we are using standard standardization technique here right now. Now, just one thing you remember, that in case of standardization or normalization, whatever you have used, see here one term is 92, another term is 22, one value is 140, another value is 8, 11, 160. So this is a huge variation. No? So reduce this variation. So we have to reduce this variation. That is why we are going to use this standardization. So generally we are using the standardization is X chain and Y test in X segment. Y segment we are not using. We can use there also. It's not a problem. Now, what thing to observe, that here you write fit underscore transform, and here you write only transform. Okay. So what is the meaning of it? Here you write sc dot fit underscore. What is sc? Sc is these values, the standard scalar. Okay, is a function, and where you are going to fit this transform. You are transforming the data. So what is the difference between why you not write fit underscore transform in case of test, when in case of training, extrain, you write fit underscore transform? The reason behind here, you learn your model or the when it's transformed to the or you transfer to the scaled value, your training sample know the fit value. Fit value means the output case. So that is why training always started with fit. Fit means we know the output values. And here we are not writing transform, means based on this fit, transform this test values. Based on this training fit, transform the test value. Okay, so that is why we are using fit in case of X train, and we are not using X test. Okay, so if you execute it, you get the result. So for example, you get the result from -1 to +1 or something like that. So the values are reduced. It is not earlier that 95. The difference is going to be reduced. Okay, similarly for white test is. Okay, so these values are going to be reduced. So this is all about the feature scaling. Now our feature has been scaled, and we can start the prediction. Now for prediction, I'm using the second data set. I'm not using this data set because this data set, the prediction accuracy is not good enough. So that is why I'm using this data set for prediction. Okay. These are say this is a data set of steel rolling process. So we know that there are various type of process, say hot roll, cold drawn, anneal cold drawn, sporodyte cold drawn. Okay, so this 0 indicates say for us hot rolling process, 1 indicates cold drawn process, and so on. And our aim is to, based on these properties, say tensile strength, yield strength, elongation, reduction in hardness, based on these properties and the compositions, so like iron, manganese, carbon, carbon equivalent, sulfur, phosphorus. So based on this composition and these mechanical properties, can we predict the process route? So if it is so, then we can say, okay, if anybody wants if anybody have this information and they want to know the process route, they can easily do it. Okay. So based on this, we can try to understand this process route. Okay. So let's try to examine this. So what I do, I'm going to classify this. So first execute this one. This one. Just a minute, let me turn on. It will take hardly 10 minutes, not more than that. So it is executing actually. Extra time. Okay. And from here, I just execute this also. Okay. So I'm now we are ready to building our neural network. So as of now, we are we know that how to pre-process the data. These are same for each and every cases if the data are not pre-processed properly. Okay. So here for classification purpose, I'm using a TensorFlow. TensorFlow is a Python package which is used to execute machine learning problems. We read this file that ce.csv, and then we read the head values. Okay. So now what is our aim? Our aim is to distinguish this into X and Y. Okay, so X and Y. So this is why I write Y is equal to df dot process. So that means Y value was stored this df dot process, and X having the values only this this parameters or features. Okay, so X are having apart from this process. So I stored process inside a list, and I drop that list from this data set. So from this df actually. So X is having this value. So if you print X dot head, you can get the result. Okay. And then I try to show that how many Y values are there. So different Y values said how many hot rolled, how many cold drawn, how many solidized cold drawn, and in cold drawn are there. So I execute this. So here you can get that 61 hot rolled and 47 cold drawn and so on. These are the data are going to be visualized. So these two are very negligible, 2 and 3. Actually, this data set is very small. Machine learning algorithm is generally we use for a large amount of data, but for understanding purpose, we are using this small amount of data. Okay. Now, there are several features. You can see magnesium, iron, manganese, carbon, tensile strength. So we can find that correlation matrix, correlation coefficient, better to say. So from this correlation coefficient, you can understand that how composition related to the mechanical properties, how mechanical properties related to the composition, and so on. This is the Peterson correlation problem. And this is how you can get these correlation values. So if you know that in any correlation you can find the direct values. From here you can get some physical understandings, like if you increase the yield strength, elongation going to be decreased, or vice versa. It's not. See, here it is. This range is going to be in lie between -1 to +1. So -1 means there is a negative correlation from each other. So one is going to be increased, other is going to be decreased. 0 means there is no correlation, and 1 means there is a highly correlate to each other. Now again, I'm splitting these values because this is my new data set, so that is why I'm splitting these values. So X10 Y test and Y10 Y test the 7. Okay, and I use the standard scaling technique. Okay, so after this, what to do? So these are the feature scaling process. Okay, now from here our model going to be start. So building model. Here is building the area. This is the okay. So how you start it? Say there is a sequential model we are going to create. Sequential means it's step by step follow model, step by step process we are going to follow. So here also we are using the sequential steps now. So first it goes here, then this, and when you back, it is also follow the sequential process. It is not jump one phase to another phase. Okay. So we have to add the input layer. So input layer and the first hidden layer. So here input dimension 11 means there are 11 number of input parameters are there. In our case, here 2 number of parameters are there. So input dimension is 2. In our case, it is 11 in this case. Units means number of neurons. So I write here the number of, as the number of input parameters is 11, writes that number of neurons in very first layer is also 11. Okay. And activation function is ReLU. So ReLU is the activation function. Okay. Now I have introduced one more hidden layer. So it's add the more hidden layer, that is it's having 6 neurons. So earlier it is 11 neurons. So now it is having 6 neurons, and activation function is ReLU. Third one is output layer, which is final output having 4 units, 4 neurons. Why it is 4 neurons? Because you can see that we have 4 output class 0, 1, 3, 0, 1, 2, 3. So 4. Is not it hot rolled, cold drawn, annealed cold drawn, and realized cold drawn. Now, in case of binary classification, here we should write 1. And in that case, instead of softmax, I am using, we have to use what? Sigmoid. Okay, we have to use sigmoid. Now, why I am showing this? Because if you search on internet, you can find each and every result. This data are also available on internet. You find that these results are available with binary classification. Very rare you can find. It's very, once you search a full page, then you can find a full multi classification using neural network. Okay, so that is why I thought that this would be more beneficial for beneficial to all of us. That is why I'm choosing this. Okay, so I use softmax as activation function and 4 in output layers. Now we have to compile this. Okay, so how we compile? So that means compile means we have to train it. Okay, we have to train it. So how we compile is, so we are we have to use some optimization technique. So here we are using adaptive momentum optimizer technique. If there is a root mean square error, RMSE optimization technique is also there. Loss. So if you talking, if as we are talking about why category cross entropy loss we are going to use. If you use sigmoid binary cross entropy use. Now here you can see we use sparse underscore categorical. Why sparse? Because you can see that our data in a form of, if you see it in terms of this, so it is the formula is a WIXI. Here it is written. So WIXI W1 length plus W2 width plus B. So somehow your weights are going to be sorry, the input is going to be transpose, isn't it? So it is X transpose W plus B. It is something X transpose W plus B when you input it to the, because it is rows or columns are going, it is earlier it is in row format na, but we are fitting it into the column format. So that is why row going to be transported. That is why we are using parse. Okay. So just so that is why we are using this parse here. Okay. So if you fit it, you it will execute. Okay, I have not run this. More minutes. So run already done here. Then you have to evaluate your model. So ANN.evaluate, which you can evaluate. So you get 86% of accuracy, and through which you can take a normal value, a single value prediction, so whether it is correct or not. Say you take any values, say for example, these values you have taken. Say for example, you have taken a value from here. This value you have taken. Okay, you just choose. Check whether it is. So it is belongs to the first attribute. It is belongs to true. True means the class 1. Okay. So that means our model is predicting good enough. Now, obviously, there is one thing that I missed that is a cross validation. Cross validation is one of the essential to understand that whether your model is overfit or underfit. And then another way of you have to design your model in such a way so that you can calculate the different uh, uh, accuracy measurement, say precision, recall, F1 score, or confusion matrix, and so on. So from here, you get this, and you get the accuracy of 0.96 as a 96% accuracies. You get the F1 score. So what is the meaning of this F1 score? Sorry, this this confusion matrix. From here, it is say 12. Say for example, hot rolled are there. So all hot rolled are predicted correctly, but one periodized cold drawn technique is not properly corrected. It is treated as anil cold. So there is some error. So that is why it is deviated from the 100% accuracy. Okay. And cohesion kappa is one of the measurement of your efficiency. So if it is closer to 1, that means it is good enough to use the model. Okay. So we get 0.9, so it's also closer to 1. So obviously we can use this. So this is how we can uh, use how can implement the CNN. Okay, so what is the aim of this study? So from here we can see that if we increase the number of data, so from here we can see that what are the possible solution to understand what is the feasible process route. Okay, so these are the one of the solution for mechanical metallurgical sector. Okay, and I believe that this will be helpful in their sector. So with this, I'm closing my session. If you have any queries, any interaction, if you want to meet, please do. Thank you.
Thank you, Dr. Amita Chaudhary, sir, for your valuable
Yeah.
time spending us. Thank you so once
Thank
again.
you very much. Thank you.
Sir, one query is there. Just a minute.
Yes, please. You are not audible. Sorry,
Sir, he's asking question. Just a minute. Mr. Dr. Participant Rajasekhar.
Sir, very good morning, sir.
Good morning, sir. Yes.
Sir, the example provided by you is very nice to understand, sir. And I have one clarification, sir. If I am an expert in NumPy and SciPy, whether these two tools are sufficient to do this numerical simulation?
Yeah, for basic classification and regression problem, using this tool, you can use.
Yes, sir. Because if you observe, the Python is having a rich set of supporting modules, sir.
Yes, yes.
So for every analysis, what we do with numerics, sometimes we may have to import some additional modules. My concern is this: how to get acquainted with those modules, sir, without any prior knowledge of that.
Okay. So in you can visit the Python documentation. Python
Yes, sir.
documentation is already available. So for example, you are working with density functional theory. Okay,
sir.
DFT. So for DFT, there is already available pre-packages up there.
Okay. So you mean to say that every time I have to install the pre-packages and I have to make use of that, right, sir?
Yes, yes.
Okay, sir. Understood, sir.
But for NumPy and Python, you need not to install it. It is, nowadays, whenever you install the Anaconda, this type of
yes, sir. Anaconda 3 itself is a composite structure of all these tools, right?
Yes, yes.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
Thank you.
Sir, thank you, Amitav sir. One more query is there, sir. Amitav sir,
yeah, please. Yeah, please.
Mr. Dear participant Suresh, please respond. Dear participant Suresh. Participant Suresh. Dear participant Suresh, your mic was allowed. Suresh. So Dr. Abhitav sir, I think queries are no more. He left right now.
Okay. Okay.
Thank you for your nice presentation, sir, for your valuable experience sharing with us. It is really delightful us. Thank you so much. Thank you so much, sir.
Thank you
Once
very
again.
much. Thank you. So I'm leaving the session now.
Yes, sir.
Okay. Thank you. Thank you.